Hi guys, so I'm going to be making a video for you today about even and odd functions, okay? So let's first talk about what an even and odd function is, okay? So a function is even, okay? So this is like the definition here. If for every number x in its domain, the number negative x is also in the domain. So what does that mean? This is pretty much like your definition. It means whether I have a negative x or a positive x, they are equivalent. So whatever's going on in the graph on the negative x side is going to be exactly the same as whatever's going on the graph on the positive x side. So for example, let's take this point here. If this point was 3, 2, right? That means when I put a positive 3 in for the x, I get an output, right, or a y of positive 2. What this means is that if I had the negative version, right, this point right here that matches up, if I had a negative 3, I would also get a positive 2. See how these points here, whether I put a positive 3 in, I get the 2, or a negative 3 in, I still have a 2. So it's symmetric about the y-axis, okay? It's even if and only if it is symmetric with respect to the y-axis. So that means if I were to fold it right along the y-axis, it would map right onto itself. Okay, so whatever's going on the negative side of the graph, right, it looks exactly the same of what's going on the positive x side of the graph. That is what it means to have an even function. Okay, so odd function. This is an odd function, all right? The definition, this is the definition here, right? This means when it's odd, it's kind of like the x's and y's are opposite. So what it means is if I have my negative x of the function, it's going to be opposite the entire function. So what do we mean by that? Let's take this point here, okay? Let's say that this point is 2, 1. This point right here, okay? That means that there's another point down here that it's going to be the opposite x and the opposite y. Right? So if this is positive 2, positive 1, this one over here is going to be negative 2, negative 1. Okay, that's just an example of the coordinates. So what does that mean? It means if it's an odd function, it's symmetric with respect to the origin. So what I like to say is check this first quadrant here and this third quadrant here. See how they kind of look like the reverse? So whatever's going on the first quadrant, the reverse is going to be going on over there. Okay, the origin is right here. Okay, so it's symmetric about the origin. So that's how you know if it's odd. So if you have a negative x, it's the opposite. It's the opposite of f of x. All right, so that's how you know an odd function.
Hello, Amy?
I'm making a video. Please give me 1 sec. You can come in, but I'm just making a video, so sorry guys. Okay, so here's an example. So we're going to be determining whether each of the graphs are even, odd, or neither. Hi. So this is an example of an even function, okay? This is an even graph. Why? Because if you were to fold it right on the y-axis, it would map right onto itself. Okay, so that is an example of an even. Okay, here, next. This is an example of something that's neither. It's neither even or odd. Why isn't it even? Because if I were to fold it right there on the y-axis, fold it, it's not symmetric, right? It's not symmetric about the y-axis. It's not symmetric about the origin either. Look at my little trick that I showed you. Check the first quadrant, check the third quadrant. Okay? It is not symmetric about the origin. Okay, your x's and y's are not the opposite signs. So this one is neither. And then here's an example of odd. This one is odd. Okay, it's not even because it's not symmetric about the y-axis, but it's even, it's symmetric, about the origin. So that means it is odd. All right, so those are some examples of the graph. Now, what we're going to be doing for the rest is finding it algebraically. So this is what you're going to be doing for your assignment, for homework. I have the two definitions up here, right? So if it's even, so what we're going to be doing is we're going to be replacing x with negative x. And if it's even, when I replace the x with negative x, it's going to be exactly the same. Nothing's going to change. That's how I know it's going to be even. If it's odd, when I replace the x with negative x, it's going to be the opposite of the entire function. That means every single term would be opposite sign. That's how you know it is odd. And if it's neither, then it's neither. All right, so let me show you here. So determine algebraically whether the graph is symmetric about the y-axis, which means even, or with respect to the origin, which means odd. So again, I'm going to first start by just, instead of an x, I'm going to put a negative x. So I'm replacing this with negative x, and I'm going to just rewrite it with a negative x. Use your parentheses. All right, so what does that mean? What is negative x squared? Right, if I have a negative x times the negative x, isn't that positive x squared? Right, negative x times negative x. Isn't that positive x squared? Right? Okay, so that's positive x squared minus 5. All right, you see how I wound up with x squared minus 5, which is the same exact thing that the original function was? So that's how you know that this is an even function. Okay, let's do this here. Now, again, I'm going to replace g of x. Instead of an x, I'm going to put a negative x, and we're going to see what happens. So instead of an x here, I'm putting negative x cubed minus 1. All right, so what is this? This is negative x times negative x times negative x. If I have a negative times a negative times a negative, negative times negative is a positive, times the negative, it's going to stay negative, right? This is odd. So it's negative x cubed minus 1, right? Now, you might look at this and say, well, that is the opposite of this. It is not. It has to be the opposite of the entire thing. So it has to be the opposite of x cubed minus 1, which means it would have to be negative x cubed plus 1. If this were plus, then it would be odd. But because it's not the opposite of the entire original function, every term, then this one is neither. Okay? So that's how you know. So your assignment is going to be, I'm going to give you a practice on determining algebraically if it's even or odd. So you just replace the x with negative x. If it's exactly the same, it's even. If it is exactly opposite, meaning everything is opposite, every term, then it is odd. And if it's neither, then it's neither. Okay? Any questions? Let me know.